This particular experiment was carried out for the first time on the spring equinox of March 2025. Two schools on either side of the Atlantic Ocean, one in Germany and the other in the United States, took measurements which I will present to you now. In Germany, the shadows of three 150-centimeter rulers were measured, giving a latitude of about 48.5 degrees, give or take half a degree. In the United States, the shadows of five individual meter sticks were measured, giving a latitude of almost 39 degrees, give or take about a quarter of a degree. In Germany, solar noon was observed at 12:31 p.m. local time, while in the United States, solar noon was observed at 1:10 p.m. Between different time zones and daylight savings time, that works out to a 5-hour 21-minute rotation of the Earth, which is only about 22% of a full day, which means it's about 22% of a full 360-degree rotation, so the calculated angle of longitude between the observers is 80 degrees and 15 minutes. This is almost enough to calculate the Earth, but first we need to do a little trigonometry. Take the latitude measurement. If we look at a cross-section of the Earth, then we see that your latitude is complementary to this angle made with the Earth's axis. Now we have a side of the triangle laying in a plane tangent to the North Pole. We can do this with both locations. Now that we have two segments in a plane tangent to the North Pole, we find that the angle between them is the longitude between the observers. We can also construct a third segment to complete a triangle, which is significant because that also completes a second triangle which contains a special angle, the one that subtends the great circle arc that is the shortest route between the two observers. A couple applications of the law of cosines and a bunch of algebra later, we arrive at this equation. If you'd like to see a full derivation, check this timestamp. Now, having this angle is crucial because this is the angle that Eratosthenes used to measure the Earth. Ours was just a little harder to get, so I think it's only fair that we take the easy road for a change and just look up the distance online. According to Google Earth, these two measurements were taken 6,540 kilometers apart. That distance is an arc of the Earth's circumference subtended by this angle, so if you work it out, you get a radius of 6,672.5 kilometers. That's less than a 5% error.